Welcome back to Basic Mathematics. In this video, we'll be looking at divisibility rules. Before we get to that, I invite you once again to take a minute, sit down, and get yourself into the right mental space for learning mathematics. Close your eyes. Take a deep breath. Breathe in. Breathe out. We're starting off at the very beginning. For many of you, this is all review. For some of you, this is new material, but that's okay. Spread your notebook out in front of you. Get ready to write some things out. We'll spend a few minutes talking about math, and then you'll have some more practice problems to take a look at. One more deep breath. Breathe in. Breathe out. We've got this. Let me get my head out of the way and we'll get started. At the end of the last video, I mentioned that the reason we were drilling addition, subtraction, multiplication, and division was not so that we could see 7 times 12 and say, oh, that's 84, but in order to see 84 and say, oh, that's 7 times 12. The factors of a number are pairs of numbers which multiply to give the original number. So, when we're thinking about factors, there are a couple of tricks that we can use. The easiest one is to just recognize the useful factor right away. But of course, that doesn't always happen. So let's look a little bit more closely at an example. Let's take a look at the number 36. One nice trick we can use to find the factors of a number is to just start writing things out. We always start with 1. 1's a great place to start. 1 times anything is that thing, so 1 times 36 is 36. After 1, we try 2. Right, if I take 36 and I divide by 2, that's a little bit tricky. That's not one you probably know offhand, but you can take a couple of minutes and work it out and realize that 36 is 2 times 18. Then we go to 3. Right? 3 is actually pretty easy. 36 is 3 times 12. After 3 is 4. And thinking through a few minutes, remember that 4 times 9 is 36. After 4 is 5. Well, 5 doesn't really work. There's nothing you can multiply times 5 to get 36. After 5 is 6. And 6 times 6 is 36. We end up here in an interesting situation where you have a number times itself, which is a very easy place to say, now we're done. If you go through this process and you get to number times itself, you are done. The other thing you might do is end up going past where you already are. For example, if I take a look at the number, say, oops, wrong pen. Take a look at the number 24. 1 times 24, 2 times 12, 3 times 8, 4 times 6. We try 5. 5 times 5 is 25, which is not 24. Right? 24 is not divisible by 5. The next number after 5 is 6. And because 6 is already on the list, we don't have to try it. As soon as we go through the list and get to the next number that is already on the list, even if it's on the other side, that's another sign that we are done. So you can use this process to generate all of the factors of a number without having to go through literally all of the numbers. It's a nice shortcut and a place to know when to stop. The multiples of a number are exactly the opposite. Right? The multiples of a number are the product of the original number and some other number. You can list out the multiples by counting by that number. For example, if I want the multiples of 8, well, I'm just going to count by 8. 8, 16, 24, 32, 40, 48, and so on. The interesting relationship. If a number is a multiple of 8, then 8 is one of the factors of that number. Right. I'll write that out using variables, which is a little bit higher level than what we're technically looking at, but I think it'll make sense. If a big number that I represent as capital N is a multiple of a smaller number, which I'll represent as lowercase a, then the smaller number, lowercase a, is a factor of capital N. And as we go through this course, there will be several times when being able to identify factors or multiples of a number is incredibly important. Those of you moving onward, you'll see that again in future courses as well. When we talk about factors and multiples, it only makes sense to mention this idea of a prime number. A prime number has exactly, missed a word in there, 2 factors, 1 and itself. Now, 1 times anything is that thing, so 1 and itself are factors of any number. The exactly here is the important thing. A prime number has no other factors. You also end up with a weird corner case. 1 has 1 factor, just 1. So 1 does not have 2 factors, which is a little bit strange at first, but it works and it allows us to do a number of other things. So it's one of those things we kind of just don't worry about and we accept. So 1 is not a prime number. 2 is a prime number. 3 is also a prime number. 4 can be written as 2 times 2. So 4 is not a prime number. 5 is a prime number. 6 is 2 times 3, so that's out. 7 works. 8 does not. 8's 2 times 4. 9 is 3 times 3. 10 is 2 times 5. 11 works. 12 does not. 13 does. 14 is 2 times 7. 15 is 3 times 5. 16 is 4 times 4. 17 is the next number that works. Then 19, 23, 29, and so on. There are a couple of places where prime numbers are useful. One of which is a way of finding factors iteratively. If you can find prime number factors of a number, you can kind of whittle down the number to get to the place where you need to get to. We call that process prime factorization. And it's, again, a nice shortcut for finding the factors of a number. Let's look at let's take a look at the number 42. You probably know most of the factors of 42 offhand based on what we talked about in the previous video and practicing the 4 fundamental operations. But even without that, you might notice something like 42 is even. And if you remember from a previous math class, you may have learned that whenever you have an even number, you can divide it by 2 and it works out evenly. And in fact, that's exactly what we do here. We rewrite 42. If you take 42 and divide by 2, you get 21. 2 is a prime number. 21 is not. 21 is 3 times 7. So we can take 42 and we can rewrite it as 2 times 3 times 7. And if we want 2 factors of 42, we can rearrange these prime factors so that the ones that we want are together and then the leftover ones are together, and it gives us a shortcut to finding the factors of a number. But with that idea of prime factorization, going through that, I took advantage of the fact that any even number can be divided by 2. Which is an important skill in its own. If you don't remember, an even number is a number that ends in 2, 4, 6, 8, or 0. And that's a very useful skill for looking at factorization. Is the number even? Well, then it's divisible by 2. Is the number not even? Well, then it's not divisible by 2. And in fact, it's not going to be divisible by any even number. There are similar rules for divisibility by 5 and by 10. A number is divisible by 5 if it ends in a 0 or a 5. A number is divisible by 10 if it ends in a 0. There are divisibility rules for other numbers that are a little bit more complicated. One of the key rules that you should know offhand is when a number is divisible by 3. If you add the digits together and ask, is this number divisible by 3? If the answer is yes, then the number you started with is divisible by 3 as well. Which is not all that much help if you have a number like 27. You should know offhand that 27 is 3 times 9, which is divisible by 3 immediately. But you can also look that 2 plus 7 is 9. And we know that 9 is divisible by 3. 9 is 3 times 3. You can use this trick with larger numbers. The number 123, if I add 1 plus 2 plus 3, I get 6, which is divisible by 9. No problem. If you have larger numbers to work with, (1,472). If I add 1 plus 4 plus 7 plus 2, 1 plus 4 is 5, 5 plus 7 is 12, 12 plus 2 is 14. I don't think that 14 is divisible by 3, but I can always double check by taking 1 plus 4 to get 5. 5 is not divisible by 3, so 1,472 is also not divisible by 3. Nice, easy way to figure out divisibility by 3. And then 9 follows a very similar rule. Why can I not write the word divisible today? So you can check divisibility by 9 by adding the digits together and determining if that result is divisible by 9. Those 5 rules are the easy ones to work with. And when you're testing for divisibility, very often that will satisfy everything you might need. There are a couple of other rules that show up in some corner case applications. My favorite is if you multiply a couple of these together. Right? 2 times 3 is 6. A number is divisible by 6 if it's divisible by both 2 and by 3. 3 times 5 is 15. A number is divisible by 15 if it's divisible by both 3 and 5. There's a rule for 4. The rule for 4 involves checking just the last 2 digits of the number, which is not all that useful for a 2-digit number, but when you have a very large number, that can help. And then once you know that, a number is divisible by 12 if it's divisible by both 3 and 4. There are rules for 7 and 11 as well. I will be quite honest, I don't really know them. I just know that they do exist. They are very rarely useful. There are 2 skill drill assignments remaining in this week's activities. One on identifying the factors of a number, the other on identifying the multiples of a number. Take a look through those 2 using some of the skills we've talked about today. And once you have done that, you are going to be ready to take the first mental math quiz on the idea of number sense. That quiz will be the end of your assignments for the week. So once you've done with that, you can take a break, and I'll see you again next week.